This invention has the capacity to achieve for the internal combustion engine something like the large efficiency gains introduced by James Watt's re-engineering of the steam engine. The theory has been proven using a single-cylinder computer model produced by an independent expert in the field at Glasgow University at a cost of £15,000. This indicates that improvements in overall mechanical efficiency can be expected to exceed 15% in a single-cylinder engine and possibly exceed 30% in a multi-cylinder engine. It is applicable to engines of all sizes, from static and ship's engines to pilotless aircraft engines. The concept requires that the sump is sealed to create a low-pressure vessel acting directly on the underside of pairs or other numbers of pistons. This is obviously a twin-cylinder application. The existing exhaust valve is modified by altering the profile of the valve lift cams to open following the fuel burn part of the cycle at some point before piston bottom dead centre. Two additional external valves, say electrically operated, divert exhaust pressure from the cylinder to the sump via a duct formed between sump and exhaust manifold or to the existing exhaust system. Pressure transfer is achieved by closing the new electric exhaust pipe valve and opening the new electric valve in the sump duct. The pressure is then sealed in the sump by closure of the new electric valve, and remaining cylinder exhaust gases are then vented to atmosphere by opening the new electric exhaust valve. Pressure tapped in the sump is now acting on the undersides of both pistons, driving them upwards during the synchronized exhaust and compression strokes, which normally use parasitic energy stored in the flywheel. As the exhaust compression strokes approach the end of their travel, both new electric valves are opened to vent sump pressure to atmosphere. The resultant smoother flow of power will permit reduction of flywheel mass and possibly complete elimination of the need for a flywheel. Further perceived improvements are realizable by injection of a small quantity of water directly into the cylinder at the point following fuel burn, where the engine exhaust valve and new sump valves are open. This would introduce advantages of instantly increasing sump pressure, reducing possibilities for reignition of any remaining fuel, and, since heat is removed from the cylinder and piston, reducing need for external cooling. This may in fact prove possible to eliminate the entire cooling system in a water-cooled engine, with consequential reduction in total engine mass and reduced pumping losses. Since some waste heat is now converted to power as opposed to being dumped to atmosphere, even greater increases in efficiency would logically be achievable. Also, the need for the cylinder wall to be a good conductor of heat from the cylinder might also be eliminated, simplifying realization of the use of plastic materials for engine, piston and cylinder manufacture. You may ask why this has never been spotted before now. I believe the reason lies in the fact that experts in the field are so brainwashed into believing that all performance of any internal combustion engine can be identified and assessed by the PV diagram that they have failed to look elsewhere. Here, the additional power output is achieved outside the cylinder, hence has little perceptible impact on PV diagrams. The overall effect is to convert the standard single-acting engine to double-acting compound equivalence with minimal design change. The simplicity of the modification lends itself to possible retrospective incorporation in existing engines worldwide, including developing countries. Hence, there is a massive potential for planetary environmental gains with greater impact than any other methodology currently being pursued. Existing engine designs and new prototypes could readily be altered to accommodate the concepts with minimal new tooling, handling, materials or test rig changes. There are also military implications associated with reduced vehicle mass, increased power and or increased range. By comparison with electric on symbiotic engine arrangements, this eliminates any need for heavy-duty electric batteries using toxic materials. Unlike electric and compressed air engines, power is not derived from remote electricity generators. Since realistic hydrogen-powered vehicles are estimated to be at least 10 years away, this invention offers the best prospect for an instant fix, utilising current proven safe technology, given government willingness and incentives. Thank you.